Welcome to part 7 of Mathematics through Induction, Roman numeral multiplication. Now that the Babylonians have a system of numerals, a system that can keep track of large quantities of numbers, and they know how to add and subtract with that system, they're able to trade with their neighbors. Traders are able to keep track of large quantities of goods and to go from town to town, picking up different types of goods and selling them to other towns to provide them with goods that they aren't able to make on their own. And this is a huge benefit that increases the wealth of all of the different city-states involved. And so let's follow the trader Ark, who's an Egyptian trader. And he is visiting one of the princes of Babylon, and he's here to sell that prince some cats. This exotic, the cat, an exotic animal from Egypt that's great as a pet. And he tells the prince, why don't you buy 5 of my cats, one for each of your 5 children, so they can have a little friendly animal companion. The prince says, great, how much is each of the cats? And Ark says, each of the cats, they're very rare, so they'll cost 15 pieces of gold each. The prince says, great, how much does that mean if I want to buy 5? And so Ark has to do a calculation. He's got to add 15 to itself 5 times. However, at this stage, he doesn't want to do that over and over again. So he has sort of a trick. He looks at this and he sees, okay, well, clearly I have to just repeat X 5 times, once for each cat, and then repeat V 5 times, once for each cat. Group all those symbols together, just like addition, and we get 50, 2, 10, and 5. That's what the prince will owe him. All right? So you can see this is a shortcut for repeated addition, which is basically just multiplication. Ark will now use this system consistently. Whenever he has to repeat a certain price a certain number of times for each thing he's selling, he just repeats each numeral in the first number by each numeral in the second number. And this is a basic kind of multiplication. And this is valid, of course, because of G4. Each Roman numeral stands in 1-to-1 correspondence with a certain number of units. V stands in 1-to-1 with 5 items. X stands in 1-to-1 correspondence with 10 items, etc. And so as a result, you simply repeat each of the numerals in the first number by the quantity represented in each of the numerals of the second number. All right. And then you just add all of the resulting numerals, and that will come out with your final sum or product, since this is a multiplication problem. All right. Now, as he starts doing this over and over again, he starts to notice some patterns. He can see that a certain number multiplied by another, or a certain numeral multiplied by another numeral, will always come out to the same sum every single time. So if he can just write down those relations, that'll speed things up. What's this called? Multiplication table, right? So let's use the following example to induce a multiplication table. Let's say Rom is selling 17 kegs of beer. The Egyptians are known for that beer. And each of those kegs of beer is going to cost 25 silver. How much silver is going to be owed by whoever this lucky man buying all the beer is? So first, again, he has to repeat each numeral representing the silver by the quantity represented in each numeral representing the beer. Okay, so first he has to repeat X times. All right, so he goes ahead and he gets a ton of X's, compresses it though, it's just C. Okay, so he can write that on a piece of papyrus for future reference. X repeated X times is C. Okay. Next, he has, and then later on, he'll have to repeat V X times. Okay. And so he writes out all those V's, and it comes out to L eventually. So he can write that down on his papyrus multiplication table, that when you got 10 groups of V, it's just L. All right. Then Then eventually, as the problem goes on, he'll have to repeat X V times. Okay? He writes out all those X's, and that's L also. So here he discovers something kind of interesting. when you repeat Vx times, it's the same as when you repeat x v times. And he's going to discover that this is true of all of the different reversals of all of the multiplication operations. He's not sure why this is yet. We don't have enough inductive evidence to prove the commutative property of multiplication yet. But he's going to notice that this is a thing, and so when he, on his little papyrus sheet, he's going to have only a certain set of multiplication relations, with the understanding that if you ever get the reverse of it, it's the same thing. Again, he doesn't know it's generally true, but he knows it's true for this limited list, and this is all he needs to conduct repeated addition, aka multiplication, right? So he has his multiplication table. Let's use that. You can go ahead and write this down, maybe pause the video and write this down so you can understand the next example, and then so you can do the exercises. So let's go back to our problem and let's do it out entirely. Again, he's selling 17 kegs of beer, and each of those beer costs him 25 silver, all right? Now, each numeral has to be multiplied by each other numeral, so we'll actually lay it out in this grid here, all right? And so first we'll go column by column, all right? So first we have to do x multiplied x times, that's c. Then we got to do x multiplied x times again, that's another c. Then we got to do v multiplied x times, that's L, using the multiplication table. Moving on to the next column, we got x multiplied v times, that's L. Then we got x multiplied v times again, that's L again. All right, so you can see there's a lot of repetition here. V multiplied v times is XXV, looking at that multiplication table again. Then we got x multiplied twice. Well, that's two x's, right? Another two x's. And then we got two v's. Now, then what Arc is going to do, he's going to take all those numerals, smush them together, and find the product. All right? And that's how much the beer costs. So we have understood a consistent system using this new concept of repeated addition, multiplication, to speed up certain problems when you have to sell someone, multiples of certain items, or generally, whenever one quantity is repeated a certain number of times, you can simply use these multiplication relations, the times tables, to speed that process, repeating each numeral in the first number by each numeral in the second number. So go ahead and use those multiplication tables that you hopefully wrote down. You can go back to the middle of the video to have that multiplication table and use them to complete the exercises. And these exercises, what I find, at least when I give them to students, is it gives them a strong idea of what multiplication actually means. Believe it or not, it's easy to forget that multiplication means repeating numbers, repeating something. And I think the reason this is because we jump directly into teaching kids Arabic numeral multiplication. In Arabic numeral multiplication, the times tables are harder to understand. You have to memorize a bunch of different items, right, for those times tables. So as a result, I think kids tend to treat it as a big memorization game instead of really focusing on why each of those answers is true. With Roman numeral multiplication, you can clearly see why each of those things is true. So because you're literally seeing the repetitions and how that leads to a particular answer for each aspect of the multiplication table. So make sure you only use Roman numerals for those exercises, and I'll see you in the next video.